Hi, I'm Hamilton, doing it the Kiwi way. Don't be intimidated by this. We'll get through it in a tick. First, we do our equation. Q is equal to A and B, and our dot is equal to and this can be omitted. And just a reminder, plus is equal to or. Also, this bar above a symbol or a variable is equal to not. So Q equals A and B. For the pull-up network, QP is equal to A or B, all knotted. And for the pull down network, which is nMOS's, equals to A or B, A and B, sorry, all knotted. The truth table, got our inputs A and B, and our output Q. Zero, zero, 0, 1, 1, 0, and 1, 1. If all the inputs are 1, then the answer is 1. Else the answer equals 0. So we've got our equations and our truth table. Let's do the nMOS of it. We have our VDD. We have our resistor. And it's A and B. A and B. Ands are in series. And our answer pops out here, but we've got all knotted. So what we do is this part here is the inverter. So we need to do an inverter. So we've got our VDD again. We've got our resistor. And what we want to do is to put in our inverter. And that goes off to ground. And out pops our answer here, Q. This here, these are basically two networks, if you can say. We've got an inverter here, and we've got AND here. See, N, A, and B all inverted. So you could call this, we'll call it for now, the interim result C. And if we do our truth table for C, C is an output of A and B. C is basically not A and B. So invert. So Q is the inversion of C. Now we've done our nMOS, let's do our cMOS. Remember, we replace the resistors with the pull-up network, and a pull-up network is this one here. So we'll start off with, we'll draw the pull-up network first. A or B, so that's in parallel. B and A. And the pull down network QN is A and B, so run out a bit of room again. Out comes C, which is our interim result. And then we'll do another VDD here and do it again. Whoops, I've got my little bubble there. And that can be done slightly differently. I'll try and tidy that up a little bit. We got our answer Q here. Just tidying it up because it looked a bit messy before. And that looks about right. So this is our cMOS implementation of the AND gate. If all inputs are 1, then the answer is 1, else the answer is equal to 0. Right, let's go on and do our OR gate. The OR gate, if one or more inputs are 1, then the answer is 1, else the answer is 0. So Q is equal to A or B in our truth table. See the writing, A, B, and the output is Q. Zero, zero, 0, 1, 1, 0, 1, 1. If one or more of the inputs are 1, then the answer is 1. So we've got one or more here, so it's 1, 1, 1. Else the answer is 0 if it's not that. So there's the truth table for that. Now the pull down network we'll do this time is A or B all knotted. And the pull up network is A and B all knotted. So the nMOS implementation of this, we've got a VDD here, we've got our resistor, it's got A or B, so it's in parallel. My diagrams are getting worse with time. The answer pops up here, and we'll call that interim result C. We can put the C here if you want. And then we need to invert it. Whoops. We'll do another network for the inverter. And a resistor here. And our ground here. And the answer pops up here, Q. That's the nMOS implementation. Now let's do the cMOS implementation of this. So just a little reminder that we're replacing the resistors with a pull-up network, which is A and B all knotted. So pull up A and B, so that's in series, A and B. I've got my little circle again. And then we do our nMOS or pull down part, which is A or B, which is in parallel. A or B. We've got our interim result here, C. And now we'll replace this resistor again with a pull-up. Sorry about that, I had to stop recording, got a telephone call. Right, put our ground down here. Oh, I forgot my ground down here as well. So our interim result C. Now we need to replace this resistor with a pull-up network and keep this nMOS. So we've got another VDD up here. Got an answer Q coming out here. And voila, done. And just quickly check it. Yes, that's all done. VDD, remember, is VDD is equivalent to VD to ground. And that's our power supply, which is we'll be using it in the lab, so it'll be about 5 volts. Right, here's another representation of cMOS, OR, and we do our ORs like that. Got Q coming out here, got 2 inputs, A and B, and we can do that a bit nicer. Note the omission of the circle here, the knot. I think that's about it. Feedback's always welcome. Right. Next, we shall go on to the XOR and XNOR gates.